Hi, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to Introduction to Data Analysis in our Part 7, which is the final part of this workshop. So the link to the material is down at the bottom, and we're on the final summary page that should look something like this. Now, this course has given you a brief introduction to the tools that can help you read in, analyse, and plot your data. Now, I must emphasise this has just been a very brief introduction, and it's just to sort of show you what is possible so you can then go on and learn more yourself. Now, you can learn more from these really excellent free online resources. So, for example, there is the book R for Data Science, which is really a must read book that really shows you how to do data science with R. There's ggplot2, Excellent Graphics for Data Analysis, which again is an excellent book that shows you how to use ggplot for drawing, really nice high quality graphs. There is Advanced R. This book goes deeper into the R programming language. And then if you want to do more kinds of data analysis that maybe we haven't touched on within this workshop, there are things like text mining with our tidy approach, which shows you how to use tidy principles to perform text mining and sentiment analysis, statistical inference via data science, a modern dive into R in the tidyverse, which teaches statistical techniques using R in the tidyverse, and the R graph gallery, which is this massive showcase of different ggplot graphs covering pretty much every type of data visualization you would want to perform, and the examples come with code. And indeed, what I would suggest is that when you want to draw a graph, have a look through the graph gallery. And indeed, let's have a quick peek at this now. Find the graph that you like. So sort of pick the type that you're looking for. Maybe you want to draw pie charts. And then from there, you'll have examples which will show how to draw those pie charts using ggplot once you have some clean data. And that's really the best way to learn, is learn by looking at examples from other people of trying to do what you want, trying to create a graph without looking at something else first is really, really difficult. So copy something which already exists. There's nothing at all wrong with that. And then finally, some people would like to use their data analysis and make it into an interactive web page that can then be used as a dashboard for other people. That's done using something called Shiny, and there is the book here called Mastering Shiny, which teaches you how to use Shiny to turn your tidyverse R data analysis and visualizations into these interactive dashboards and web pages, which you can then share with others. So that's everything that you have to do on this workshop, but kind of quite a challenging, kind of fun thing if you wish to do at the end is this bonus exercise. And for this, what I'd like you to do is look at that ggplot2 book, and I'd like to see, could you find out how to make a graph of the decadal temperature that we plotted in the last section just a little bit prettier? So could you change the axis titles to temperatures in degrees Celsius and year, and change the points color to red instead of being sort of the default color? And then if you really want to push things, see if you could change the color of the points so that the low temperatures are blue and higher temperatures are red. Now, if you press pause, have a go at this if you want to, and then unpause and I'll walk you through the answer for this. Okay, you've now unpaused, so I'm going to assume you want to see the answer for this. So let's have a look at the answer. So let's create first a new notebook. So I'm going to do File, New, R Notebook. There we are, remove the boilerplate because we don't need this now. And then save this as, I'm going to call this Pretty Graph .r Markdown Notebook. Of course, you can call it whatever you would like. First thing we need to do, as always in all of our notebooks, is load up the tidyverse. And there we are, it's now loaded. Okay, the next thing is we want to read in the data. So again, I'm just going to copy and paste this here. This is what we've seen before, where we've been loading the data up, cleaning it, and then creating the column at the end, which has decade. There we are, that's now run through. So historical temperature now has a decade column, just as we've seen before. Okay, the next thing we need to do is we now need to basically work out how, let's take the first unpretty graph actually. So let's draw the graph that we had, which was not the nice, clean, wonderful version. So that was this graph here, which I showed you how to draw at that point. So remember, this was basically filtering on December, grouping by decade, and then basically creating an average of the December temperatures for each decade, where we then plotted on an aesthetic where decade was on the x-axis, the average temperature for the December temperatures across that decade are on the y-axis, and then we plotted that both as a scatter plot and a smooth line plot, like this. So this is the unpretty version, and what we want to do is we now want to change the axis titles. Now, from this chapter, which is linked, of the ggplot book, or looking at this link here for the ggplot documentation, you can see that you can add text annotations to the plot in many different ways. So for example, if I open this in a new tab, you can add text annotations in many different ways that are listed. So there are labels and others, and again, this is very good. The documentation is showing you exactly what you need to do. Now what we're going to be doing is using the labs function, and the labs function is a layer that's added to the graph, which adds the layer for the title for the graph and also for the x and y axes. And so we're going to add those layers onto the graph by adding them at the end. So I come here, I'm adding on the labels for the title and the subtitle, and the label for the year and for the temperature. There we are, temperature in Celsius, year on the bottom, and then we can see, look, nice little title and subtitle. Notice for the degrees sign, this is a Unicode symbol. Unicode is available, pretty much has all the symbols, and you can find Unicode symbols basically by looking at the Unicode website. So here, if I look at the Wikipedia page, here's the degree symbol. You literally just copy and paste it, and that's how you can put it into your book. So like Control C, and then here, look, I'm just going to Control V it. And we live in a world now where it's very easy to get symbols just from Unicode by finding them. Now, text labels, Unicode covers all of the languages in the world, and it also includes emojis. So if you are being really kind of like fun, you could actually copy an emoji and put that into your graph. Oh, it hasn't quite rendered it. I kind of feel slightly happy that it's not rendered it onto the graph actually, but as you see, it's quite easy to put emojis into text, and so definitely control yourself, just put in like symbols that would be proper to put in for a proper graph. Okay, so now that we've got the title, subtitle, and the x and y axis titles nicely set, the next thing to do is to look at the temperature. So at the moment these points are plotted in black. We would like to sort of draw them in red. And what you can do is basically change the color within the aesthetic. So in this case we've used geonPoint, and we can change the color of the points by passing in the color argument to the points. So if we do that, and now we run, you can now see the points have been sort of drawn with red, which looks maybe a bit prettier. But what if we wanted to do the sort of the advanced sort of optional thing, where instead of drawing the points with one color, we instead drew them so that the hotter temperatures were red and the cooler temperatures were kind of like blue. Now we can do that by assigning color scales to data. So the first thing we need to do is set the color aesthetic equal to the data series, and this actually comes, as you can see here, it's described in full how to do this in this chapter of the ggplot book. So what we need to do is we first need to basically, in the main aesthetic that's used, say how we're going to be specifying the color. And in this case, we're going to say the color scale is going to come from the average values. So in other words, we're going to color it by the average value, and in this case we don't need to specify the color within geonPoint. So if we do this and then run it, you can see now that we've got the colors scale coming from the average, where low colors, low temperatures at around 2 are sort of dark blue, and high temperatures are kind of like light blue. Now, this color scale is the default that's been selected, and to be honest, it's not really what we want. You can't really see the difference between what we have here. Now, You can look in the ggplot book and you can see that there are a number of predefined colour scales, and the one we want is red to blue, which is given the name RDBU, which scales from red to blue. Now, to apply the colour scale, we need to either use Scale Colour Brewer for discrete data or Scale Colour Distiller for continuous data. And as the average temperature is continuous, we'll use Scale Colour Distiller, and that gets added on as another layer on the graph. So we do add on that layer. It's continuous data, so it's Scale Colour Distiller. You can see there's many different ways we could be actually creating these colour scales. And the palette we'll use, which says how the colour scale will work, is this RDBU, meaning go from red to blue. There we are. So what's happened here is we have the average value is basically put in the middle and is coloured as white. Below average values are now coloured with blue, moving down towards the minimum, and the above average values are coloured via red, moving up to the top. Now the colour scale legend that we have on the right here, maybe it's not really necessary. And so what we could do is we could actually turn that off. And again, the way that we turn this off is we add a theme to the graph, and themes are covered within the ggplot book. And that's another layer. So basically it comes off to smooth. And we're going to, in this theme, we're going to say that we don't actually want the legend to be positioned anywhere. So if we say legend position equals none, then that will basically say don't place the legend anywhere. And so it's gone. And so that gives you the answer for the advanced exercise. And again, if you want to learn more about themes and how you move things, it's then you have the themes chapter of the ggplot book. And again, I do encourage you, look at the gallery of graphs so you can sort of see how to get started. But if you really want to dive into how to use ggplot, this is a very good book to work through and to get things sorted out. So that's basically covered the bonus exercise. I hope that was useful. And as I said, once we've kind of given you an idea of what's possible with R, it's not everything you could do. So once you're happy with this workshop, we do have subsequent workshops, including the applied data analysis in our course, which will start to show you how to apply more advanced techniques, such as machine learning, to the data. And finally, just as credits of this workshop is based on the Introduction to Data Analysis in Python workshop created by Matt Williams. All of the text of this workshop, but not this video, is published under a Creative Commons Attribution license, and all the code snippets that you've seen are MIT. Source code for this material can be found on GitHub, and we welcome any fixes or any comments that you have. Thank you for your attention and for working your way through this entire workshop. I look forward to seeing you in a future workshop. Goodbye.